66 million years ago, a rock 6 miles wide slammed into the Earth at 45,000 miles an hour. The impact vaporized instantly. Wildfires swept entire continents. The sky went dark for years. Roughly 75% of every species alive on the planet died. Every dinosaur that wasn't already a bird, gone, completely, within a geological blink of an eye. And somewhere in the ash and the darkness, a small ground-dwelling bird, roughly the size of a chicken, walked out the other side. This is what birds know. Every single bird alive today, the one at your feeder, the one nesting under your roof, the pigeon on the sidewalk, is a direct descendant of a small number of bird lineages that made it through that exact extinction event, when essentially nothing else its size on land survived at all. Scientists have spent decades trying to answer one specific question. What did that handful of surviving birds actually have that every other dinosaur, flying reptile, and large land animal on Earth did not? Subscribe to What Birds Know so you don't miss what comes next. Because the answer isn't about being fast or strong or smart. It's about something far stranger. Start with the obvious question. Birds are dinosaurs, not descended from dinosaurs in some loose metaphorical sense. Birds are technically and scientifically dinosaurs. Every bird alive belongs to the theropod lineage, the same branch that includes Tyrannosaurus and Velociraptor. When that asteroid hit, it didn't kill the dinosaurs and then the birds survived separately. It killed every dinosaur lineage except one narrow branch of small, feathered, flying theropods that had already been around for tens of millions of years before the impact. Fossil evidence from Antarctica, New Zealand, and North America has helped researchers piece together which specific bird lineages actually made it through. And the pattern that emerges is remarkably consistent. Every confirmed survivor lineage shares two specific traits: small body size and the ability to eat seeds. Body size mattered enormously in the immediate aftermath. Larger animals need more food, more consistently, to survive. In a world where the sky was dark with ash for months or years, where plant growth collapsed globally, where entire food chains fell apart from the bottom up, being small meant needing dramatically less to survive each day. A chicken-sized bird could scrape by on a fraction of the calories a larger animal required. But size alone doesn't explain it. Plenty of small animals died too. The second trait, the ability to eat seeds, turns out to be the more decisive factor. And it's the part of this story most people have never heard. When the asteroid hit, it didn't just kill plants and animals directly. It effectively shut down photosynthesis worldwide for an extended period as soot and dust blocked sunlight on a massive scale. Living, growing plant matter, leaves, fresh shoots, most fruit, became scarce almost immediately across the entire planet. But seeds are different. Seeds are essentially dormant plant packages, built specifically to survive harsh conditions and remain viable in soil for months or years, waiting for better growing conditions to return. Researchers studying the fossil record and modeling post-impact ecosystems have found that seed-eating birds had access to a food source that simply didn't require the sun to keep. Functioning in the short term, vast reserves of seeds already on and in the ground before the impact, essentially a stockpile that could sustain small populations through years of ecological collapse that killed off species dependent on fresh, actively growing food. This is where the story gets genuinely specific. A 2011 study examining fossilized bird beaks from right around the extinction boundary found something striking. Species with beaks adapted for crushing and processing hard seeds are disproportionately represented among confirmed survivors, while species with beaks adapted for eating insects, fruit, or fresh vegetation are almost entirely absent from the fossil record immediately after the impact. Modern ostriches, emus, and ducks all trace back to these early surviving lineages. And interestingly, many of their closest surviving relatives from that immediate post-impact period were in fact ground-dwelling and seed-focused in their feeding strategy. Even species that would later evolve toward completely different diets once conditions stabilized and food sources diversified again. Think about what that actually means. The specific ancestor of nearly every bird you will ever see in your entire life almost certainly survived a global catastrophe, specifically because it happened to already have a beak, shaped correctly for cracking open seeds, and happened to already be small enough to survive on the calories those seeds provided. Not because it was smarter, not because it was tougher. Because of an incredibly specific, almost accidental combination of physical traits that turned out to be exactly what a completely unpredictable global catastrophe demanded. There's a term researchers use for this kind of evolutionary luck: exaptation. When a trait that evolved for one original reason turns out to be perfectly suited for solving a completely different, unrelated problem later. These early birds didn't evolve small size and seed-cracking beaks in anticipation of an asteroid impact. Those traits developed over millions of years for entirely ordinary reasons, competing for food, filling a specific ecological niche among a world still dominated by larger dinosaurs. And then, in a single catastrophic afternoon that no evolutionary process could have possibly anticipated or prepared for, those same ordinary traits became the single most important survival advantage on the entire planet. Every larger, more specialized theropod dinosaur, many of them faster, stronger, and by most measures more impressive than a small ground-dwelling bird, died out completely. The small, unglamorous seed eater made it through, not through any advantage related to intelligence or power, but through pure evolutionary circumstance, meeting an almost impossibly specific set of post-impact conditions. Paleontologists studying this specific transition period increasingly describe it as one of the strongest documented examples in the entire fossil record of exactly how unpredictable mass extinction events actually are. Survival determined less by which species seems objectively better by any conventional measure, and more by which species happen to already possess, for completely unrelated reasons, the exact narrow set of traits an entirely unforeseeable catastrophe would specifically reward. Every bird you will see for the rest of your life carries this story inside it, whether it's currently eating seeds, insects, fish, or anything else entirely. The specific ancestor that made survival possible in the first place was almost certainly small, ground-dwelling, and built to crack open seeds during the darkest, most food-scarce years this planet has ever experienced, years when almost every other large animal on land simply ran out of options and disappeared. From that narrow surviving population, over the following tens of millions of years, birds diversified explosively into every ecological role imaginable: soaring predators, deep-diving fishers, nectar-feeding specialists, apex land predators like the terror bird, even briefly, giants larger than any bird alive today. But every single one of those later, wildly different lineages traces back to the same starting point: a small, unremarkable bird that happened to be exactly the right shape and size on exactly the wrong day for almost everything else on Earth. The next time you watch a bird crack open a sunflower seed at your feeder, you're watching a behavior that 66 million years ago may have been the single deciding factor in whether birds existed at all today. If this changed how you think about where birds actually came from, subscribe to What Birds Know and hit the bell so you don't miss the next one. And tell me in the comments, which prehistoric or extinct bird do you want covered next?